In this video, we're going to look at the relationship between white light and color by recreating a portion of Newton's prism experiment, as presented in a letter to the Royal Society in 1671. But first, working on designing lenses for telescopes, we decided to investigate the phenomena of prismatic colors. Those are the colors that occur when you pass white light through a prism. So he obtained a triangular prism, and he passed some white light through it, and he saw a rainbow, just like he expected. But then he noticed something. In the direction that the colors were spread, the pattern was much wider than it should be based on the system geometry if light obeyed this fixed sign ratio law. So he did some experiments. He separated out individual colors in the spectrum and passed them through additional prisms, and what he came to realize was that all of the colors in this spectrum are their own form of light, and they all experience a different refractive index on traveling through these prisms. So this led him to the conclusion that the white light entering the prism wasn't really white, it was a combination of all these different colors, and that all the prism was doing was separating them in an angle by this varying refractive index. This is an interesting conclusion, but it doesn't really prove what's happening because we're still relying on this prism to make these colors. So what we really need is an experiment where we can form these colors from white light without a prism, and at the end of his paper, Newton suggests just such an experiment. You start with the same system you had before, and then you place a lens in the system. We start with our screen close to the lens, and we see the same spectrum we saw before. Here is the light passing through the lens, and up above it we see the light that's sort of skipping the top of the lens. As we move our screen away, the colors begin to overlap until at one point we see a band of white light. As we continue to move the screen further away, we see the same spectrum that we started with, but with the colors now reversed. As we move the screen in this experiment, there's nothing to cause this change of color that we're observing. The only thing that's changing is the overlap of the colors. So we can conclude that when we perceive this white light, what we're really seeing is a whole bunch of colors added together.
The wonderful world of color. There's no such thing as color. We live in a colorless world. Color is an effect produced in our eyes and brains by light. White light consists of different lengths of light waves. Each wavelength produces a different color sensation. A banana looks yellow because its surface absorbs all wavelengths except yellow, which is reflected back to our eyes. In the same way, a cherry looks red because its skin absorbs all colors except red. And vanilla ice cream gives the illusion of being white because it reflects all wavelengths of light. So, color doesn't really exist, but it does have a very real effect on us.
The cornfields dot the hillsides where once there were hickory and chestnuts.